This is St. Raz, and we are continuing on in our Python 3 journey on the Solo learning app on the Mu emulator, emulating an Android environment. I'm certain that Solo Learn is available in an Apple environment too, so if you have an iPhone, that should be fine as well. Last time we had gone through about 7 of the 9 lessons covering exceptions and files, and we're going to go ahead and pick up there. Should be able to finish that before moving on to the next section. The Module 4 quizzes. There are 9 sections, and then there's the 10th is the Module 4 quiz there. So, writing to files. To write to files, use the write method, which writes a string to the file. So here we use file, assignment operator, we call the open function and pass in the name or the path in the name of the file that we're opening. We use the W switch as the second argument to indicate that we're writing, and then we call the write method on the file object that we just created, and then we pass in the argument is the text that we're writing to it. And don't forget to close the file when you're done with that. Now here we've already written. Now we're going to open the file and then print, call read, the read method on the file object, and that's going to print what was written to the file. This is coming out of the file after we wrote to it earlier, and then we close the file when we're done. The W method, the W mode will create a file if it doesn't already exist. Which line of code writes hello world to a file? Okay, let me see. That's not right. File write hello world. I think that's the one. That is it. I was thinking file equals open blah blah blah. This would be the line that writes to the file after we've already opened the file and declared the file object and everything. Let me see. Next one. Writing files. When a file is opened in write mode, the file's existing content is deleted. So when we open that file to write to it, if we had anything in it before, it is gone. And this is not uncommon. This is common to a few programming languages, and usually there is an append function as well as a write function. A write function is going to make it'll basically be a brand new document but with the same name as the old one. So, and this is just writing to it. This is just a series of writing and then opening it to write more and demonstrating that the previous content was deleted. As you can see, contents of the file have been overwritten. What happens if you open a file in write mode and then immediately close it? That's a good question. I believe it's deleted when you open it. So I would believe that the contents would be deleted. Yep. So once you open it, even if you don't write anything to it, it is deleted. So the write method returns the number of bytes written to a file if successful. Mount written file write SG. That's interesting. I didn't know it returned anything, but apparently it does return hello world. So that would be what, 12 bytes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, including the space and the exclamation point. That is 12. That could be useful. To write something other than a string, it needs to be converted to a string first. So, files are all strings all the time. If you want to write an integer or a float or something else, you're going to have to convert that to a string and then write it in. And of course, if you need to use a file to store integers or floats or some other data type, you will pull those as strings out of the file and then convert them to the data type that you would need for your program. So files are all strings all the time. If a file write operation is successful, which one of these statements will be true? File write message. Actually, this would be true because the write method, calling the write method on a file will give the length. So I believe that one would be it. Yes. File write message equals true. That doesn't really make sense because this is going to return the length, not a Boolean value. This is not exactly true either because this is going to return the length in bytes. It's not going to return the contents of MSG, which is the file. If MSG is the file, then that's a string, and the length is going to be an integer, the length of the number of bytes. Okay, so now you're comparing two different data types, a string and an integer. So that's not going to be correct either. And working with files. Thought we'd been working with files. Let me see. It is a good practice to avoid wasting resources by making sure that files are always closed after they have been used. One way of doing this is to use try and finally. And this ensures the file is always closed even if an error occurs. Okay, well that's good to know. So if there's an error, it's possible that in writing or reading from a file there could be an error. If there is, that could kind of throw a monkey wrench in things. Program could terminate maybe. Maybe you could throw an error and then the file is still open. We don't want to leave them open, so that way by using finally we invoke the file object. In this case it's just identified as an F here, and then we call the close method on the file. When the close function will the close function get called in this code? This is basically exactly what we just talked about. So we've got the try block. The try block is either going to work right or it won't work right. There'll be an exception. Either way, the finally block will always run. So the close function will get called either way. So yes, it will get called. An alternative way of doing this is using with statements. This creates a temporary variable, often called f, which is only accessible in the indented block of the with statement. And I have never heard of the with statement before. That's a new one for me. With open file name.txt as f print f.read. Temporary variable. So we've got the with. The with has another keyword as. So we've got with, open, and the as is going to assign the name here, which in this case is f, as the variable, the temporary variable, and then we use it here. The file is automatically closed at the end of the with statement, even if exceptions occur within it. Oh, that's how it works. So we've got the with, and then we we've got the with, we open our file, specify our path and name there. We use the as keyword to name the variable, temporary variable name. Then we've got our indented block of code, and then once the with block finishes, it automatically closes. Well, that's convenient. Fill in the blanks to create a valid with statement, reading the contents of the file. So we've got a with statement as f print reading the contents. So this is going to be a read, and that should do it. There we go. And we're ready for the Module 4 quiz. This will only take a few minutes, and we should make a little dent in our next big section. Which number is not printed by this code? Try print 1, print 20 divided by 0, print 2. Now here, 20 divided by 0. Okay, that's going to throw an exception. It's except 0 division error. Now because it is catching this exception, it's going to use this. It's going to print 3. The finally prints either way. So whether the try completes or if an exception is thrown, as long as that exception is handled, which a 0 division error is handled in this case. So the finally will print either way. Actually, you know what? Even if it was a different error, the finally would still run. So the finally is going to run either way. So we've got 1, 3, 4. This is going to throw the exception, so we're not going to reach 2. So 2 is not going to be printed. Open the file in binary write mode. We're opening a file here, so we've got open, and then inside the parentheses we've got our arguments. Assuming it's the working directory, we don't need a path, so it's just the name of the file. We're opening it to write right there. Binary mode, we need a B right here. Fill in the blanks to try and open and read from a file. Print an error message in case of an exception. So try, let me see, open and read from a file. Okay, so we're going to do, what was that one? Let me see. What was the keyword? Was it next? I forgot our brand new keyword. Let's do F there. We've got an exception here. Except. I need a hint. What was it? That brand new word. With. That's it. With. They had me stumped there. We have very few programming keywords in Python that I'm not familiar with, because these are keywords in multiple other languages. The only one that's really unique to Python that I've seen so far is elif, E-L-I-F. I've used languages that use else space if, and else if with no space. elif was the only one that was new to me, and that's easy enough to remember. It's just a matter of a couple of letters are left out. With, I haven't seen in any other language that I've worked with, so yeah, hence my bad memory with it. Okay. What is the highest number that would be printed by this code? So we got another one of these. basically what we're looking for is something that's going to break, like an exception or something. So we've got the try block start, or the try keyword with the colon, then this indented area is the block. So we've got print 1, we've got assert 2 plus 2 equals 5. Well, that's not true. That's going to throw an exception, except assertion error, that's the exception it's going to throw. So we're going to print 1, we're going to print 3, let me see, and this is except print 4. This doesn't specify what kind of error. If we have no specification on the type of error and the type of exception that is thrown, then it's going to execute this block no matter what the type of the exception is. So the 4 should print. So now it will print the 3. This is going to catch it, but this should catch it as well. And maybe I'm wrong about that. Oh, you know why? It's going to catch the assertion error here. Because it catches it here, it doesn't go down here. And I think, oh, I can't go to the code playground for it. But because it catches it here, it doesn't fall through to this one. Now, for finally, it would go either way. If we had switched these two around, it would print the 4 but not the 3 because it had already caught it before it got there.
Our online store is our business. How are you backing up your data? And the more you look at that, the more you want an app like this to take care of it for you.
Okay, and we're going on more types. Yeah, I'm assuming they mean data types. None. That's interesting. The none object is used to represent the absence of a value. It's similar to null in other programming languages. Like other empty values such as 0, this is the open and closing brackets, but there's nothing in them. Okay, and the empty string, which is a string that doesn't contain any characters. It can have a name, it can be called, but it doesn't contain any characters, and that's including white space. You can have a string containing one or more spaces in it and no other characters, or you can have an empty string, but if it has spaces, it's not empty. It is false, none, again, this is what we're talking about. None is false when converted to a Boolean value. When entered at the Python console, it is displayed as the empty string. So none equals none, that is true. None, let's see, print none, and it does display none. What is none often used to represent? Absence of a value. It says a false value. If you wanted to represent a false value, you would want to use a Boolean. You can use a Boolean, a variable that's set to false, or you can just use the Boolean value false, but you wouldn't want to use none for that, even though none converted into a Boolean is false. An absent value is different from an invalid value. In fact, in order to be invalid, I'm not sure. I would think in order to be invalid, you would have to have a value there. To have no value is different from being an invalid value. The none object is returned by any function that doesn't explicitly return anything else. So that's similar to returning null or returning void in other programming languages. Def sum func, print high, var equals sum func, print var. Okay, so print var, So basically we are calling the object, we're calling the function. It does print high, but then it returns none. And I'm not sure why. See, print for, oh, I see what's going on. If you just call the function, let me try something. I think if you just call the function, it will print high. But if you print the function, it will list the value too. Let me try this. Ah, I was right. See what we're doing here? When I put just the name of the function here, var, it invokes the function, it calls the function. When we call some func, it prints high. Okay? But there's a difference between calling the function and print var. When I print var, it's going to call the function, it's going to print high. But when I print and then the name of the function, it's also going to display the value that the function returns. And if the value doesn't return anything, it returns none. That is interesting. When you learn your first programming language, it can take a lot of work to figure out why it does the things it does and everything. When you learn your second programming language or your third programming language, when you learn the first one, you just you're new to it. And when you learn how things work differently in the second or third or subsequent programming language, you realize there is a different way to do things. When you learn the first one, it's like, well, how else would you do it? And when you learn the second or third or fourth or whatever, you find out the other ways that it could be done. And that's very interesting. Okay, what happened to spam and eggs? They're using foo now. Though we didn't use foo in bar. This is Python. This is a silly place, like it's Camelot. Alright, what number does this code print? Foo, we're going to assign print to foo. If foo equals none, print 1, else print 2. Okay, print, when we've created functions earlier, print usually doesn't return a value. It does something, but it displays text or numbers or whatever. It displays things, but it usually doesn't return a value. So foo, if print is assigned to foo, then the return value for print would be none. So if foo equals none, print 1, and then otherwise print 2. So I think it's going to be 1. I'm not 100% on this. I am correct. I'm going to go to the comments and see if I'm right. For the reason I think I'm right. More explanation. And I'm having trouble with scrolling. Here we go. Who is assigned empty string, but this is string object. Yes, the text was just printed. Why are they naming the variable poo? That's ridiculous. Look at this. Sylvia wants to know where spam and eggs went. You can do everything with spam and eggs. Okay. Anyway, it looks like the consensus is that we can that the print function doesn't return. It may print, it may display, but it doesn't return a value, and that's why it behaved in that manner. So dictionaries now are data structures used to map arbitrary keys to values. Lists can be thought of as dictionaries with integer keys within a certain range. Dictionaries can be indexed in the same way as lists using square brackets containing keys. Okay, now you'll notice, why are they using the curly braces? Maybe you can use curly braces and square brackets. I'm not sure. Print ages Dave, ages Mary, so it would display 24 and 42, just like that. Each element in a dictionary is represented by a key value pair, and those are separated. The key and the value are separated by a colon, and the pairs of keys and values are separated by the comma you can see here. Fill in the blanks to define a valid dictionary with two elements. We need, oops, that's the wrong character. We need the, oops, why did I really do that again? There we go. Okay, and the missing characters were the colon between BMW and blue, the comma between this pair, and then to close the dictionary definition would be the curly brace to the right. Trying to index a key that isn't part of the dictionary returns a key error. So print primary red, then print primary yellow. There is no yellow, so that would give an error, key error, and then it specifies what input incited the key error itself. And let me see, an empty dictionary is defined as, and then open and close curly brace with nothing contained within. Now, we've been using a lot of white space makes a difference in Python. So we've been using a lot of indentations and separate lines for different things. It looks like you can put separate items, separate pairs in a dictionary on different lines here. So that's something to keep an eye on, especially if your dictionary is large or if there's the part of the key value is long, and you might look at things wrapping around being difficult to see, to read. So putting each one on one line, not a bad idea for readability's sake. What is the result of this code test? And this is that aforementioned empty dictionary. Print test 0, and 0 is basically we're putting in a value, a key value. 0 would be a valid key value, but it's not contained in this dictionary because it's empty. So it's going to throw a key error. Only immutable objects can be used as keys to dictionaries. Immutable objects are those that can't be changed. So far, the only mutable objects you've come across are lists and dictionaries. Trying to use a mutable object as a dictionary key causes a type error. And this is a bad dictionary. You'll see in this pair we've got 1, 2, 3 here, but it's enclosed in the bracket here. That's a list. And a list is a mutable object. It can be changed. And since the key in dictionary key value pairs is not supposed to be a changeable thing, it's supposed to be immutable. So this is a bad dictionary. And the type error is unhashable type. list. And we may get into hash tables later. I'm not sure if exactly how hash tables or hashes are handled in Python. I guess we'll see that together. Which of these values can't be used as a dictionary key? Interesting. False? Can we use that? This is a string that's immutable. So that's actually okay. Are dictionaries immutable? I think dictionaries are mutable. Dictionary keys have to be immutable values, but dictionaries themselves, I'm pretty sure, are mutable. Therefore, a dictionary cannot be used as the key for another dictionary. Dictionary functions. And just like lists, dictionary keys can be assigned to different values. However, unlike lists, a new dictionary key can also be assigned a value, not just ones that already exist. So we've got squares, 1 1 2 4 3, error 416. Squares 8 4 3 9. Okay, so you see we would be able to change the values, but we would not be able to change the keys. What is the result of this code? Primes. Let's see, 1 2 2 3 4 7 7 17. Okay, so we need print primes. Okay, so primes 4 would be 7. Primes 7 would be 17. So it would be printing 17 if I didn't get lost. There we go, it's correct. And you will, there might not be a lot of situations in real life where you'll have things that are nested quite like this, but these deeply nested structures, like you might have even 3 or 4 deep, are very common in exercises or in homework and such, to make sure you understand exactly how that works. So be on the lookout for those. To determine whether a key is in a dictionary, you can use in and not in, just as you can for a list. So see, print 1 in nums. Okay, and that's not going to print the value that has the key 1. It's just going to return the Boolean value that indicates whether 1 exists as a key in the dictionary. So as you can see here, 1 is there, so it returns true, or it displays 2 rather. And then print 3 in nums. 3 is right here. 3 though is not a key. 3 is the value to the key, which is the integer 3. So that indicates false. Print 4 not in nums. There's no 4. Well, that comes back true because we've got the not there. So if we did print 4 in nums, it would be false, but 4 not in nums, 4 is not in nums, therefore it's true. And we've got to drag and drop from the options below to print yes if the key 112 is present in the dictionary named pairs. So if, let me see, if 112 in, what's the name of our dictionary? Pairs. If 112 in pairs, print yes. That should be it. Yep, there we go. A useful dictionary method is get. It does the same thing as indexing, but if the key is not found in the dictionary, it returns another specified value instead. By default, that would be none, which makes sense. So let me see. Print pairs get orange, and the result, see, there's orange. The result would be 2, 3, 4. Right there. Pairs get 7. 7's not in there. Okay, so it indicates none. Then print pairs get 1, 2, 3, 4, 5, not in dictionary. Don't see 1, 2, 3, 4, 5. So it just prints not in dictionary. Okay. And what is the result of this code? Fib. It's going to be the variable name, the name for the dictionary. 11213243, and I don't see any rhyme or reason there. And then print fib get 40. Got a 4 there, so that would be 3 plus fib get 7, 5. Okay, there is no 7, 5, so that'd be none. So I think it would just print the 1. Is it just going to print 3? I don't know about that. Yeah, it looks like I'm wrong. So 40. If the key is not found in the dictionary, it returns another specified value instead. Oh, okay. So we've got 2 arguments. So the first argument is what we're looking for. If it's not there, it returns the specified value. The specified value is the second argument. We may not have a second argument, but if we do have one, that's the argument that it returns. Okay, so going on to do this again. So we've got fib get 4. There is a 4, it's 3. So we've got 3 plus fib get 7. There's no 7. Okay, if it was just 7, then it would return none. Okay, but we're specified. If there's no 7, return 5. So we've got 3 here. Okay, and then plus 5 since there's no 7. So 3 and 5. So that would sum to 8. There we go. We're learning together. And tuples. Tuples are very similar to lists, except that they are immutable. They cannot be changed. Also, they are created using parentheses rather than square brackets. Tuples is also something that you're going to hear a lot when discussing databases. Relational databases have structures called tuples. So, see, words equals spam, eggs, sausages. And it looks like they're using the comma at the end of this one as well. You can access the values in the tuple with their index just as you did with lists. Print words 0. Words is the name of the tuple. 0 would be the first one. So that's going to print spam. Well, let's see, it should print spam. It's not telling us what it's printing though. Try it yourself. Print word 0. Shouldn't it print spam? Yeah. It behaves just as I thought. They didn't specify what it would do when it was run. Trying to reassign a value in a tuple causes a type error. So here we got words 1, which is eggs. We're going to try to change that to cheese. So we're going to assign cheese to the tuple words at address 1. It doesn't like that. It's going to cause a type error. If you wanted something that could be changed, maybe use a list. Okay, so lists are mutable. You've got the elements in the list. This is not a list, this is a tuple. But you've got the elements in the list. They can be changed. Dictionaries have a key value pair. So it's a group of those pairs. The key is supposed to be immutable. The value can be changed. Tuples are not pairs. Tuples are just values, but those values, once they're generated, are immutable. So tuple object does not support item assignment. And tuples can be nested within each other. Fill in the blanks to create a list, dictionary, and tuples. So here we go, list, dictionaries, and tuples. Lists, if memory serves, use the square brackets. Dictionaries use curly braces, and tuples use parentheses, which are the gently curved type of enclosure. Tuples can be created without the parentheses by just separating the values with commas. My underscore tuple, 1, 2, 3, each element nested in the double quotes, and then each element separated from the next with commas. Print my tuple 0, which would be the first one, would come out as 1. An empty tuple is created using an empty parenthesis pair. Tuples are faster than lists, but they cannot be changed, as we mentioned earlier. What is the result of this code? Tuple 1 and then 1, 2, 3, print tuple 1. Okay, now we already discussed tuples can be nested within tuples. The tuple here, named tuple, consists of 2 elements. The first is the integer 1. The second element is another tuple consisting of 3 elements, 1, 2, and 3. Now tuples are 0 index, so when we print tuple 1, we're going to take the second element in the tuple. Is it weird that these are square brackets when tuples use parentheses? But I'm going to say it's going to be this. So tuples, we use parentheses, but when we call a value, we use square brackets. Okay, I can remember that. List slices. Let me see. I think we'll just do list slices, and then we'll wrap up the video. List slices provide a more advanced way of retrieving values from a list. Basic slicing involves indexing a list with 2 colon separated integers. This returns a new list containing all the values in the old list between the indices. So we've got squares. This is our list. Print squares, and then inside the square brackets we've got 2 colon 6, and then 3, 8, and then 0, 1. So what we've got is from 2, 6, so this is 0, 1, 2, so it would be 4, 3, 4, 5, 6. So it would be 4 to 36. Okay. Now, as with some of the other index references that we've seen, it includes the index of the first one, and it goes up to the index of the second one without including it. So what we get is we get 4, because that's 0, 1, 2. It does display the 4, so that's 2, 3, 4, 5, 6. It goes to 6, but it doesn't display 36. It only displays 25. So it prints squares 3 to 8. So it would include 3, 0, 1, 2, 3, 9. It goes to 8. That's 3, 4, 5, 6, 7, 8. It includes 49, but not 64. And then 0 to 1, it would include the one at index 0, but not the one at index 1. So it's just 0. And of course, this is their note, their informational note, that tells you exactly what I just did. Maybe I should read ahead for those to make sure I'm not getting ahead of myself. What is the result of this code? So we've got SQS, and then we've got our list here. Print SQS 4 to 7, 0, 1, 2, 3, 4. So we're going to start at 16, 4, 5, 6, 7, up to 49, but not including that. So 0, 1, 2, 3, 4. So it would be 16 to 36. Yep, that's what it is. If the first number in a slice is omitted, it is taken to be the start of the list. Oh, I see. I was going to say, how are you going to omit it? But you can omit it by just not having anything there and starting with the colon. If the second number is omitted, it is taken to be the end. So what you can do is, by omitting one or the other, you can just basically say everything up to but not including index 7, or everything starting at index 7 and through to the end of the list. And that's what we get there. And fill in the blanks to take the first two elements of the list. So we've got our list here. The first two, so we're going to be starting at 0. We separate the two indices with the colon in the first two elements. So it's going to go up to 2. So we're going to take 0 and 1, but not 2. List slices can also have a third number representing the step to include only alternate values in the slice. So let's say you want every other value or every 3 values. As you can see here, notice these colons here. So we've got no start. The second value is no end. So we want the whole thing, but the third value is 2. So it'll be in intervals of 2. So every other one, which you can see is 0, not 1, 4, not 9, 16, 36, 64. And in this one, we're starting at 2, 0, 1, 2 would be 4, and then we're going to 8, so 0, 1, 2, 3, 4, 5, 6, 7, 8 would be 64, and we're doing that in intervals of 3. So we've got 4, skip, skip, 25, skip, skip, 64, but 64 is the 8th one, or index 8 rather, I should say, and it doesn't include that one, so we just get 4 and 25. 283 would include elements starting from the second index up to the 8th with a step of 3. That's the one we just did. What is the output of this code? SQS, and then we've got a series of values there. Print SQS 1, so we're starting at 1. We're going all the way to the end because we have no value there. And then we're going to do it by intervals of 4. So we should have 1. Let's see, 1, skip, skip, 16. Oh, actually, it would be skip by 4. So 1, skip, 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 25, skip, skip, skip. Well, we'd go to 81, but that is the very end, so I don't think we're going to actually have that one. Oh, no, we are going to have that one. So it'd be 125, 81. There we go. Negative values can be used in list slicing and normal list indexing. When negative values are used for the first and second values in a slice or normal index, they count from the end of the list. Oh, that's interesting. So, let me see. Print squares 1, so we're going to start here, and to -1, okay, which would be, is -1 the last one or the one before the last one? Okay, -1 is the last one, but the index, the second index given, isn't displayed. So it would go from the second index, which is 1 since it's 0 indexed, all the way to the last one, but not including the last one. So it would be 1 through 64, as we can see here, 1 to 64. What is the output of this code? Print SQS, we're going to start at 7, go to 5, and -1. Wait a minute. Oh, okay, the slice is done backwards. So it's intervals of 1, but going backwards. I thought that was, I didn't read that well apparently. So we're going to use -1 here, so we're going to do 7 to 5. So 0, 1, 2, 3, 4, 5, 6, 7, 49, and then go 5. So 49, 36, 25, but not including 25. So 49, 36, like that. Okay, and looks like the next one up is going to be list comprehensions, and we'll pick that up with the next video. Thanks again, guys, for joining me at Cajun Coding, and as always, like, subscribe, recommend the channel. Any questions, comments, requests, or critiques are always welcome. Look at those comments, and appreciate you guys, and I'll see y'all next time.